This unassuming little building here may well be the last wheel balancing shed in the US. I'm Darren, and this is the Industrial Revolution. There's actually a couple different things you have to consider when you're balancing steam locomotive wheels, and this really just applies to the big, giant wheels, the driver wheels. First, the wheels themselves have to be balanced, but then they also have to be balanced across the locomotive. First, let's take a look at how to balance the wheels themselves, and then we'll come in here to the wheel balancing shed and look at how you balance it across the entire locomotive. So I thought this would actually be an easy video. I know how car tires are balanced. Same thing, right? Well, sorta. If you ever had a car tire out of balance, you know how much it can bounce, even damaging the car if it gets bad enough. Well, imagine how much worse that can be on a giant steam locomotive, where a single pair of drivers with the axle can weigh a ton or more. So obviously this can cause a lot of damage to the locomotive and to the rails and the rail bed too. So it obviously makes a lot of sense to balance them. Well, sometimes. First, a quick primer on locomotive wheels. The huge drivers on steam engines are actually two pieces, the wheel and the tire. Yeah, there's actually a tire on steam locomotive driver wheels. So it's really easy to see on this Russian decapod here at the North Carolina Transportation Museum. If you look closely, you can see a seam running around the wheel where the wheel and the tire connect. It's usually a few inches in from the rim. The outer part, that's the tire. Wheels are only cast once, and they usually stick with the locomotive for life. Tires, though, well, they wear down, like these ones are. You can see how deeply the groove is cut into this tire, which is going to cause the locomotive not to follow curves very well, and it's also going to increase track wear. These wheels can be pulled off the locomotive, put on a lathe, and then have that nice conic wheel shape restored. Now, if you've already done that a few times and your tire's starting to get a bit thin, then you can actually take the old tire off and put a brand new tire on. Anyway, back to the production process. So after casting the wheels, you finish them up on a lathe to make them perfectly round, and then you install the tires. Once you have the tires on, you install both wheels onto the axle, stick in the crank pin, and then, well, maybe you might balance the wheels. I've been in a few shops where they maintain and repair their own steam trains. They've had wheel lathes so they could reprofile the tires, but they haven't had any way to balance the wheels. Well, think about this. When your car tires are out of balance, you don't feel it when you're driving around town, but really only when you get up to speed on the highway. Most historic, heritage, and museum steam trains are running maybe 10 miles an hour, 15 kilometers an hour at most. You still need to reprofile the wheels now and then, but really, balance isn't so much of an issue. When trains started going much faster, though, as you started going into the mid-20th century, many railroads, especially those running bigger, faster, heavier trains, did start to put considerable effort into balancing. So the first step, you'd mount the entire driver axle onto this balancing rig, then spin it up to the full train cruising speed. The springs let the wheel set wobble, letting the operator judge the balance. The operator could then stop it and adjust the weight to balance the wheels. Now, to adjust the weight, they really had two different methods they'd use. The first and older method was to drill holes in the backside of the counterweight. These counterweights were often intentionally cast too large and heavy, allowing the operator of this machine to drill the holes in the back for balance. The second option was actually exactly the opposite, which was to pour molten lead into voids in the wheel. This became especially popular in the mid-20th century as train weight and speed went up, and with it, they developed an increased desire to cut weight from the wheels and reciprocating parts of the locomotive. The most extreme form of this weight cutting even led to completely hollow driver wheels, such as the huge 68-inch, 1727mm box-pox driver wheels on the big boy locomotive. Once the lead was added, they would often weld steel over the top of the void in case the wheel heated up enough to melt the lead later, which actually could happen. Well, by now you've probably seen at least one problem with this process, and one of these problems is fairly easy to solve. Attached to the crank pin is the heavy crosshead, and attached to that is at least one, maybe two, heavy connecting or coupling rods. Well, that weight was actually pretty easy to compensate for. They would just add a weight to the crank pin, called a bob weight, which more or less approximated the weight of those components. That really left just one, unfortunately insurmountable problem. The reciprocating parts of a locomotive move. When they do, the forces they put on the wheels actually change direction. They apply forces up and down, forward and backward, and complicating things even more, the wheel on the other side is doing the same thing, but 90 degrees out of phase, which then applies a twisting force to the axle too. Well, engineers did two things here. First, while allowing the necessary up and down movement of the wheel sets, they locked the wheel sets in place as rigidly as possible to prevent forward and backward movement, as well as side-to-side movement. Second, instead of the standard straight counterweight commonly cast into locomotive drivers, some people tried to stretch out that counterweight, curving around the wheel further in an effort to catch more of the off-balance weight. In the end, though, there was really only just so much you could do with the reciprocating parts. Now, with your wheels dynamically balanced as well as you can get them, or at least as well as you cared to get them, and different railroads cared differently about how well this was done, some railroads and manufacturers would then move on to the wheel balancing shed. Take a look at the rails in this shed. You see how they're cut into short segments? Those segments are not connected together with fish plates, so they're free to move completely independently of each other. And that's important, because on each rail segment, on each side, there's actually a completely independent Fairbanks scale to measure the weight. You'd pull the locomotive into the wheel balancing shed and stop it with each driver parked on its own scale. Now, if your designers did their job well, the weight should be pretty well balanced over the drivers, but there's still other factors at play here. Each driver set has its own springs, but those aren't necessarily well balanced to start with. Also, maybe you made changes like adding a heavy air brake compressor and tank to one side, installing a superheater, and really almost any other change, and that's going to change the balance as well. Now, fortunately, getting the weight even between each wheel doesn't have to be perfect, but you do want to get them fairly close to ensure that your drivers are actually doing their work, and also you want to minimize the rail and the rail bed damage. There were two real options for doing this. First, you could potentially add or remove weight above the bearing block to adjust the weight up and down for each wheel. Now, if you think about it, adding 20 or 30 pounds this way isn't too bad, it's pretty easy. But adding hundreds isn't going to work, and really 20 or 30 pounds at this point just doesn't matter. A better option, with the ability to adjust considerably more weight, was actually to adjust the springs. Now, there's a lot more adjustability to these springs than you'd think, and that suspension is probably worthy of a video of its own someday. But for now, let's just say that by adjusting the hangers, shims, etc., they could get all the drivers to approximately the same weight on the scales, providing the best support for the locomotive and the best ride, efficiency, and protection for all equipment. So how often do you need to do this? Well, hopefully the manufacturer did some form of this before they delivered the locomotive. After that, some railroads would never do any of it again, especially those with lower speed lines, which is why you don't see it done much on tourist railroads. High-speed lines, on the other hand, might do at least some of it, when they reprofiled the drivers every 100,000 miles or so, or when they replaced the tires completely, or made major changes to the locomotive that changed the weight distribution. So once you balance the individual wheels themselves to get rid of that nasty vibration that I'm sure you felt in your own car at some point if you had a wheel out of balance, and you've come in here to the wheel balancing shed and you've balanced the load between the separate driver axles, you're ready to take your train out and safely travel the world without destroying your locomotive, without destroying the rails. And that's why places like this are the Industrial Revolution. Hey, wait just a second before you go. I need your help to keep the channel growing here. First thing you can do is really easy. Just like, subscribe, share this video. Tell all your friends about it. That spreads the word. YouTube will see that and we'll show this to more people. Commenting more than just 2 or 3 words. YouTube says that's the most important thing you can get. It's the best kind of user interaction there is. So you can comment more than just 2 or 3 words. Also, if you're able to and are interested in helping out financially, these are pretty expensive videos to film, a lot of travel costs on top of the hours of work I do here. You can help out at patreon.com/industrialrevolution or become a member here on YouTube or a single contribution through Super Thanks. Also have an affiliate store. If you click that, anything you buy there, a percentage of that purchase will come to help fund the channel. Thanks for your help and look forward to seeing you next week.